Welcome to DragginMath. Let's learn about commutable operators. Remember that A plus B equals B plus A, always. This is the commutative property of addition. Also, remember that A times B equals B times A, always. This is the commutative property of multiplication. The word commutative means we can change the order of operands under an operator without changing anything else, and the resulting expression always has the same result. But what about other operators? Are they commutative? In standard DragginMath fashion, let's try things and find out. We'll start with subtraction. Enter 4 minus 3, semicolon, 3 minus 4. Now double tap the roots of both expressions to evaluate. The results are not the same. There might be some numbers for which this works, but it doesn't work for all numbers always. So there is no commutative property of subtraction. But what will DragginMath do if we try to commute 4 minus 3? Maybe it will quietly tell us you can't do that, or maybe it will do something else. Let's find out. You can see that DragginMath lets us make this change. The operands did switch sides. But unlike addition, other things changed also. The 3 is now negative 3, and the minus is now plus. Does 4 minus 3 equal negative 3 plus 4? You can do a little mental arithmetic, or we can use DragginMath to find out. Tap semicolon in the top row now to add another expression to what's already there. Double tap to evaluate. Yes, they are the same. It can be shown for any numbers a and b that a minus b equals negate b plus a. This always works. It doesn't have its own special name in math books, but many people call it turning subtraction into addition. This transformation is often useful. So subtraction is not commutative, but it is commutable if you remember the other changes that must go along with it. Notice that commuting subtraction twice in DragginMath doesn't change the addition back into subtraction. That's because addition really is commutative. Nothing else changes when you swap its operands, no matter how complicated they are or where they came from in some previous step. To change back to subtraction, drag the unary negate operator up onto the plus operator. Sometimes an expression subtracts something from itself. Of course, these operations evaluate to 0. You can double tap the first operator here to evaluate. But evaluating a minus a does nothing because DragginMath doesn't know the value of a. Still, we often need a way to cancel subtraction into 0, even for variables. In DragginMath, commuting a subtraction with equal operands does that. This is an important feature of the app. but not of math itself. This is only a convenient way to tell DragginMath that you want to cancel. Canceling works for more complicated operands also. And if complicated operands are not identical, but still equal, DragginMath can often, but not always, figure that out on its own. If it can't, you'll have to help it. What about division? You can easily show there is no commutative property of division either. But division is a lot like subtraction in this regard. Try commuting A over B. See that DragginMath lets us make this change. Once again, the operands switch sides. Once again, other things change also. With division, they change into invert B times A. This looks a lot like commuting subtraction. The changes have the same shape, but using different operators. Once again, this doesn't have its own special name in math books, but many people call it turning division into multiplication. And this transformation is also often useful. So division is not commutative, but it is commutable, if you remember the other changes that must go along with it. Notice that commuting division twice in DragginMath doesn't convert the multiplication back into division. That's because multiplication really is commutative. Nothing else changes when you swap its operands, no matter how complicated they are or where they came from in some previous step. To change back to division, drag the unary invert operator up onto the multiply operator. Sometimes an expression says to divide something by itself. Of course, these operations evaluate to 1. But once again, because we don't know the value of A, trying to evaluate A over A does nothing. Similar to what DragginMath does with subtraction, commuting a division with equal operands cancels division into 1. Just as with subtraction, this works for more complicated operands too. But remember to be careful about the possibility of dividing by 0 when you do this. What about the raise operator? Remember, in DragginMath, this means 2 to the third power, which is different from traditional notation. Yes, there's a good reason for this difference. Is the raise operator commutative? No, but it is commutable. Notice the 2 other things that change when you commute this. What about the root operator? Remember, in DragginMath, this means the third root of 8, which is different from traditional notation. Yes, there is a good reason for this difference. Is the root operator commutative? No, but it is commutable. Notice the two other things that change when you commute this. Is this related to the way raise commutes? Yes, it is. In fact, raise and root are just different ways to write the same idea. Something like looking through one end of a telescope and then the other. What about the log operator? Remember, in DragginMath, this means the log base 2 of 8, which is, once again, different from traditional notation. Yes, there's a good reason for this difference too. Is the log operator commutative? No, but it is commutable. Notice the one other thing that changes when you commute this. DragginMath has other operators too. For example, permute and combine. These aren't commutative, and they aren't commutable either. As you can see, DragginMath won't let you do it if you try. So addition and multiplication are truly commutative. Subtraction, division, raise, root, and log are not commutative, but they are commutable. If you remember the other changes that must go along with them. Sometimes this makes it easier to get things done. Sometimes it's even necessary to move toward a solution. Now that I've told you about commutable operators, I'll show you another DragginMath feature that does something similar. You can also convert addition into subtraction by flicking down on the operator. And you can do this. Convert subtraction into addition, or multiplication into division, or division into multiplication, all by flicking down on the operator. That's all for now.